You know, we are surrounded by these incredible machines every single day. But tucked away deep inside them are these ingenious components working tirelessly, almost invisibly, to keep everything safe. Today, we're going to pull back the curtain on one of the most important ones that you've probably never even heard of.
Just think about it for a second. You walk past a construction site, you look up and you see a massive crane. It's lifting, I don't know, a multi-ton slab of concrete hundreds of feet into the air, and it looks completely effortless. It's a sight we're all used to, right? A real testament to the power of modern hydraulics.
But have you ever stopped to think, what if something goes wrong? I mean, really wrong? What happens if one of those thick hydraulic hoses, straining under thousands of pounds of pressure, just bursts? What's stopping that huge load from just plummeting to the ground? Well, it turns out there is something. There's a specific component, kind of like a hydraulic safety net, that's designed for that exact nightmare scenario. It is often the only thing standing between a controlled, safe lift and a total disaster. And here it is. Meet the hero of our story, the double Overcenter valve. Yeah, I know, it might not look like much, just a solid block of metal with a few holes in it, but this unassuming little device is an absolute powerhouse of safety and control. So what does this thing actually do? Well, putting it simply, its main job is to control the movement of a hydraulic cylinder and then lock it solid in place, in both directions. This makes sure that a heavy load can be lowered smoothly without just running away. And it also prevents something called cavitation. That's a really nasty condition where bubbles form in the fluid and you lose all control. And what's so cool about this is that this one single compact valve is actually doing 3 totally separate and totally vital jobs all at once. Let's break them down. Okay, job number 1, load holding. Think of it like a hydraulic handbrake. The second the machine operator takes their hand off the controls and that main valve goes to neutral, this valve instantly locks the cylinder. It stops any kind of drift or slow creep from the load's weight.
Job number 2 is all about load control. Okay, so imagine you're lowering that huge concrete block. Gravity is yanking it down, right? It wants to fall faster than the pump is actually letting oil out. This valve pushes back. It creates a back pressure to make sure that the descent is perfectly smooth, controlled by the operator, not by gravity. It stops the actuator from running away.
And this brings us to the big one, its most important job, load safety. If a hose were to rupture, a catastrophic failure between the pump and the cylinder, this valve, because it's bolted right onto the cylinder itself, slams shut. Instantly, it locks that load right where it is. It's the ultimate failsafe. And let's be really clear here. This isn't just about saving the equipment. This is about people. As the experts say, this kind of protection is absolutely vital because losing control of that load could cause horrific damage to property and, more importantly, to people. So how does it pull all this off? Well, it all comes down to a really clever but kind of simple hydraulic trick that's all about pressure and leverage. Okay, don't worry, you don't need to be an engineer to get this. This is basically its internal blueprint. You see those 2 check valves with the little springs on them? Normally, they block everything. The only way to open one up is with a little push of pressure from the other side, a signal that we call a pilot signal. And that brings us to this really key idea, the pilot ratio. The best way to think about it is like hydraulic leverage. It's the secret code that tells the valve how much pilot pressure, that's the unlocking pressure, it needs to fight against the massive load pressure that's trying to keep it shut. So a really common ratio you'll see is something like 1 to 4.5. What on earth does that mean? It means for every 1 pound per square inch of unlocking pressure you send, you can safely control 4.5 pounds per square inch of load pressure. It's how a tiny, controlled signal can manage a huge, dangerous force. All right, so we know what it is, we know how it works, but why does this little chunk of metal actually matter so much in our world? Well, the short answer is it's pretty much everywhere. We're talking cranes, forklifts, all kinds of agricultural machinery, excavators and earth movers, hydraulic winches, even the lift that raises your car at the mechanic's shop. Basically, any machine that lifts and holds a heavy, potentially dangerous load is probably relying on this exact technology to keep us safe. But here's the thing. For this valve to actually save the day, it has to be set up perfectly. And there is one golden rule you absolutely cannot break. First, you figure out the absolute maximum pressure that the load could ever create. Then, you set the valve's pressure setting to be at least 1.3 times that number. So why 1.3 times? What's with that extra 30%?
That is a non-negotiable safety margin. It guarantees that no matter what, even with sudden jolts or pressure spikes in the system, that valve spring always has enough oomph to slam shut and hold that load tight the second it leads to.
You know, the double overcenter valve is just a perfect example of this elegant, invisible engineering that keeps our world running and keeps it safe. It really makes you wonder, doesn't it? What other unseen heroes are out there quietly protecting us every single day?